In this example, we are creating a micro-ROS parameter server. This parameter server will handle 3 parameters, one for each LED on the development board. First of all, we create a micro-ROS node named myRenesas node. Then we create a parameter server with the default QoSs. Later, we create an executor and add the parameter server to the executor. Here, we are setting a callback that is going to be called every time that ROS2 entity change a parameter on this micro-ROS node. Finally, we add 3 parameters, one for each LED, red, green, and blue. The type of these parameters is a Boolean value. Finally, we spin the node forever. If we check the onParameterChange callback, we can see that we are comparing the modified parameter name with the 3 strings and acting on the LED status depending on the value of this parameter. Now we are going to see how the micro-ROS parameter server works in the Renesas development board. First of all, we connect the micro-ROS client through an USB transport and click the debug button. Once the code is loaded in the board, we click on the Run button and we can see how the micro-ROS client is communicating with the micro-ROS agent. Now, in the ROS2 environment, we can check which parameters are available. In this case, my Renesas node have blue, green, and red parameters. Using the ROS2 CLI, we can check the status of each parameter. For example, in this case, we are going to check the status of the blue LED. We also can set the status of each parameter independently. Also, we can dump the full parameter status of a micro-ROS node. We can save this parameter status in a YAML file in order to use it later. Now we are going to modify the status of our micro-ROS parameter server. Let's turn off the red and blue LEDs and let's turn on the green one. Now that we have a completely different parameter status in the micro-ROS node, let's load the previous saved file in the parameter server.